2.1 functions, part 2. We're going to talk today a little bit about domain and range. If they give you something that looks like this, it says that the domain of the function is the set of all inputs. That's your x, which you're going to put in. If they write it like this, they're telling you to put in what numbers? Right here. What are they telling you? What numbers do they want you to use for x? Can I use 0? Yes, because it's greater than or equal to. What else can I use? 1, 2, 3, 4, and what? 5, okay? They're telling you the domain is between these two things. You know you can use 0 and 5 because of the equal to sign underneath. So when they give you the domain, then you know what you're plugging in. If they don't give you the domain, all right, there's some rules that we have to follow. This is a very, very, very important slide. Okay, a lot of times, if you have just an equation that doesn't have any of these three things, your domain is all real numbers, meaning you can plug in anything you want, a negative, a positive, or a 0, and get some sort of an answer out. So the 3 restrictions, which is what you guys need to pay attention to, it says the domain of every function is all real numbers, meaning if I was to write that in interval notation, it would be negative infinity to positive infinity, right? You're going to ask to be used interval notation on your web assignment and on any quiz. But there's 3 things that you have to pay attention to. The first thing is if there's a variable in the denominator, meaning, number 1, say I had 3 over x plus 2, right? This is an example for the first rule. Do you guys see that there is a variable in the denominator? Yes? Okay, so you would say, okay, wait, there's a variable in the denominator. What does it tell you to do to find the domain? What does number 1 tell you to do? Set the denominator, what? Not equal to 0. Same thing, same concept. So I'm going to subtract 2 from both sides, and you can say x can be anything in the world except for negative 2. Whenever there's a variable in the denominator, this is what we have to do. Why? Anybody tell me why? Not necessarily. You don't have to get rid of it. But what happens if I plug in negative 2 right there? What's negative 2 plus 2? 0. Can you have 0 in a denominator? No. So you have to figure out what number is going to make the denominator 0, and then that's one that doesn't count. So you would tell me you guys can use anything from negative infinity to negative 2. Can you use negative 2? No. So I have a parenthesis. Union negative 2 to infinity. That's the way in interval notation you guys would tell me I can use anything in the world except for negative 2. So the first thing you look at when they ask you for domain, you guys are going to go through these 3 rules in your head. You're going to say, first thing, is there a denominator? Is there a variable in the denominator? If there is, this is how we fix it. All right, the next rule, it says if there's a variable underneath the square root. Okay, so let's think about this. If I had, yep. Yesterday, we just plugged numbers in. We evaluated. Today, they're talking about what the actual domain is. Like, what numbers can we put in for x? So that's why it's an interval notation.
Oh, so now we're trying, they're not giving that.
Correct. They're not telling you to evaluate. They're saying find the domain. Okay. I'll show you. We'll do some more examples in a second. Number 2, it says if there is a variable underneath the square root. So say I have x minus 4. So if I said to you guys, what's the domain? The first thing you would say is there a variable in a denominator? No, there's not, right? So the second thing you would say is there a variable underneath the square root? Is there?
Yeah.
Yes. So what does the rule say to do? Greater than or equal to 0. Does anybody know why we set this square root greater than or equal to 0? Perfect. Can we take the square root, guys, of a negative number? No. So we have to figure out what would make the number underneath the radical negative, and we can't use that. So if I was going to do this, I would square both sides. When you square a square root, it cancels out. So you have x minus 4 greater than or equal to 0. What would I do to both sides? I'd add 4. So you guys would tell me that x has to be greater than or equal to 4. If I was going to put that in interval notation, how would I say that? It's got to be, think about it on a number line. I have 0 here and I have 4 here. What kind of a dot do I have at 4? Closed, good. And where are all the numbers greater than? To the right, correct? I'd go that way. So how would you guys write that in interval notation? I can use everything from 4 bigger. Bracket, good. 4, comma, infinity. Perfect. Very good. All right, there's only 3 rules we have to worry about. 1, is there a variable in the denominator? If there is, we set the denominator not equal to 0. 2, we have to say, is there a radical with a variable underneath? The third rule says what? What's that third rule say? All right, it's like a combination of both. If I had, I don't know, 4 over the square root of x plus 10. First question you ask is there a variable in the denominator? And we go, oh, shoot, there is. But this is a special kind because it's underneath a what? The variable's underneath a what? It's underneath the fraction. It's in the denominator. So in this case, guys, it tells us to take the square root and to set it what? Just greater than 0. How come this one's greater than, but the one above it was greater than or equal to? How come the number 3, I set it just greater than, huh? Okay, we want it to be positive. But why is it just greater than? It's not greater than or equal to. What can a denominator never be? 0. So I don't want this to ever be 0, because if it is, then it becomes undefined. So if you have a radical, it depends on where it is. If it's in a numerator, it's greater than or equal to 0. If it's in a denominator, it's just greater than. So again, we're going to solve this the same way. You square both sides. So x plus 10 greater than 0. Subtract 10 from both sides. And I get x is greater than negative 10. So if I was just, I need interval notation, so help me out here. Negative 10, 0. What kind of a dot do I have here at negative 10? It's open. And then where are all the numbers greater than to the right, correct? So how would you write that in interval notation? To infinity. Good. Do you guys see the difference? Greater than or equal to, I'll have a bracket. Greater than, I have a parenthesis. That's the biggest thing you have to pay attention to. Yes, ma'am. Okay. Question was for 2 and 3, what's the difference? If you look here, guys, on number 2, it's a variable in the square root. Number 3 is a variable in the square root, but it has to be where? In the denominator. It's got to be in the bottom of the fraction. That's when it's just greater than.
And when it does that, it will always do it
Open.
without the.
Yep. Good. All right, so let's move to some examples here. Look at number 1. If I said to you, find the domain. What rule is this breaking? Think about the rules. I have 3 rules. What's rule number 1? What's rule number 1, guys? Come on. A variable where? In the denominator. If there's a variable in the denominator, what do we do? Look back at that slide we just did, guys. What do we do if there's a variable in the denominator? Set the denominator not equal to 0. So we're going to say x squared minus x cannot be 0. Guys, this is just a factoring problem. What do I do here? Take out an x. Good. So I have x times x minus 1 cannot be 0. So I say x can't be 0, and x can't be what number? Well, if I solve it, I move it over, it becomes what? Positive 1, right? So you're going to tell me you can use every single number in the entire world except for those two. So if I start from left to right, I have negative infinity to what number? 0. Can I use 0 or no? Nope. Then I have a union. Then I can go from where to where? No, from where to where? Okay, 1 to infinity is going to be over here. 0 to 1, right? There's numbers in between 0 and 1. So you're telling me you can use every single number in the entire world except for 0 and 1. So you have to say negative infinity to 0, can't include 0. Then from 0 to 1, can't include 1. And then from 1 to infinity. Look at B. What does B say? Where is my problem? It's in the numerator. Good. So I have to take my 9 minus x squared and set it what? Perfect, okay. Greater than or equal to. And the reason it's greater than or equal to is because it's in the numerator. So square both sides. 9 minus x squared greater than or equal to 0, right? Yes? Okay, subtract 9 from both sides. So I have negative x squared greater than or equal to negative 9. Now what? Okay, not minus. I want to get rid of that negative 1 out in front.
Divide by negative 1.
Good, divide by negative 1. When we divide by a negative 1, what happens to our inequality sign? It flips. And then what's my last thing I do here? Take the square root. So I get x less than or equal to, what kind of 3? Plus or minus 3. So think about this. This says x is less than or equal to negative 3, and x is less than or equal to positive 3. So if I was going to do my interval notation, negative 3, 0, and 3, what kind of dots do I have here? They're both closed. All right, where are the x values less than or equal to negative 3? Okay.
So they're gonna be like, it's gonna be negative infinity, parentheses, negative infinity, comma, negative 3, bracket, and then you set it 3 again with a bracket, and then, infinity.
So you're saying like that?
What do you mean, sorry?
In the green. Let's think about this, guys.
Like that, that's what I meant.
Okay, well, let's think. Let's think. If I have positive 3, and I plug it in here, what's going to happen here? 9 minus 9 is, right? Square root of 0 is okay. So I can use 3. What happens if I plug in negative 3? Same thing, right? Negative 3 works, and so does positive 3. You guys agree with me? Okay. What's not going to work? Well, let's try. Let's plug in 0. If I plug in 0, I get 9 minus 0, so I get the square root. Well, that'll work.
And then it's gonna be changed in the middle. Oh, wow.
Well, let's pick out 4. Let's pick out 4. What happens when I square 4?
You get 16.
What's 9 minus 16?
Negative 7.
It's a negative number, right? So Duque said, well, wait, you're going to shade in the middle. We learned something the other day, guys. We learned something the other day. I'm just trying to see if you guys are paying attention to me, and I didn't think you were. When I get here at this step, how many inequalities do I have? 2. When we had 2 and we split them up, didn't we say x is greater than or equal to, what was it, less than or equal to positive 3, right? This is our original. Less than or equal to positive 3. Then what did we do to the inequality sign when we had the negative 1? We flipped it. X is greater than or equal to negative 3. Did we flip it here?
We did, but we just shoved up.
No, we didn't. Look, did we flip it? Are they both going the same way?
Yeah, but didn't you say it like that? Didn't you tell me that we needed to?
We should have, but we didn't. But I want you guys to see what we've learned the last chapter with our inequality stuff. That doesn't go away, guys. The rules are still there. But you can catch a mistake. People at home, I think you've fallen asleep on me. You can catch if you miss something, because what did I do right here at this step that took me 2 seconds to see if I was on the right track? What did I do here? I plugged in. I plugged in some stuff, and as we did that, Duque, you said to me, wait a second, if I do 4, you said, wait, it should be shaded in the middle. You see that? That is why, guys, I cannot impress upon you enough how important it is to check. A lot of you on your quizzes, as I was going through, you did not do that. You gave me answers when it should have been no solution on inequalities because you just weren't paying attention. What are the only values that I can use here for domain? -3 to 3. Can I use -3 and positive 3? Yes, you can. Good. I need you guys to pay attention and to work along with this. Please, don't just sit there. What's the next problem? What's the next issue I have? It's in the denominator, so I have to have, I'm going to use an x. X plus 1 has to be greater than 0. Cannot be equal to, just greater than. So if I square both sides, I get x plus 1 greater than 0. X has to be greater than -1. Just check this for a second. Here's -1. Here's 0. I need numbers that are bigger than -1. So if I plug in 0, here, what's 0 plus 1? 1, and the square root of 1 is 1. So we're good. What happens if I plug in -2?
You'll get negative, oh, you don't have -1?
Correct. If I plug in -2 here, -1. Well, we know the square root of -1 is what kind of a number? It's imaginary. So I can use every number from -1 bigger, but can I use -1 itself?
No,
Why?
because it would be
What's -1 plus 1?
0.
0. So we cannot use that. So I can use any number in the world from -1 to infinity. Good, Duque. All right, last one. Go through the rules. Is there a variable in the denominator? No. Is there a square root? Is there a variable with a square root underneath? No. Is there a variable underneath a square root in a denominator? No. Is there right now? Look at that. So if I don't break any of the rules, then my domain is -infinity to positive infinity. I can use every number in the entire world. You guys have got to get that chart in your brain. And you have to pay attention to what you're doing. Don't just follow along like little mice. Pay attention to what you're doing. Check. Make sure that you didn't skip something or miss a little step. All right, let's look here. I want to talk about some of these ones that you guys are going to see on the evaluating part for the second part of your homework. If they give you a piecewise function, it says to evaluate the piecewise at the indicated value. Okay, remember, you guys don't plug numbers in first and then see where it fits. You first look at the parameter. If I'm going to plug in 5, where does 5 fall? Is it the first expression, the second expression, or the third expression? Is 5 less than negative 2? Is it between negative 2 and 1? Or is it greater than 1? So you guys would use the expression x plus 4. So you would tell me 5 plus 4 is, so you would say f of 5 equals 9. This is what I need to see on your web assignment. Make sure you're doing that.
Will there not be 2 questions on the test? Or the grade?
Probably not, but I mean, no, it's not going to get much harder than that. There'll be fractions, but look at the next one, okay? F of 1/3, where does 1/3 fall? Is it less than negative 2? Is it between negative 2 and 1, or is it bigger than 1? It's between negative 2 and 1. So what does it say? What's the expression I use? Guys, that's your answer. F of 1/3 equals 3. There's nothing to plug in for x. They're telling you if your x value falls between here and here, the y output is 3. It's not a trick question. If you look at the next one, negative 9/2. Well, where is negative 9/2? How many times is 2 going to 9? 4 times with 1 left over. So this is really negative 4.5. Where is negative 4.5? Is it less than 2? Is it between negative 2 and 1? It's the first one. So you have 2x squared minus 3. So plug in negative 9/2. So I have negative 9/2 squared. Is it plus 3 or minus 3? When you square, guys, a fraction, that exponent goes where? To both the top and the bottom. So this is negative 81/4 minus 3. I can cancel here. So I have negative 81/2. Change 3/1 into seconds. If I times the bottom by 2, then I times the top by 2, so I get negative 6/2. So f of negative 9/2. When I plug in negative 9/2, I get out negative 87/2. Fractions, not a big deal. Got to be able to handle that. All right, where's negative 4? It's less than negative 2. So again, I'm going to use the 2x squared minus 3. So I have 2 times negative 4 squared minus 3. Negative 4 squared is 16. 16 times 2 is 32. So 32 minus 3. F of negative 4 equals 29. When I plug in negative 4, I get out 29. Just pay attention to the values that they give you, guys. Everybody can handle this. I believe in all of you. All right, let's look at the next examples because this is going to be on your web assignment. I want to make sure you guys understand what they're asking you to do here. If they're telling you to evaluate, everybody look, 3x squared plus 5, they want you to evaluate x plus 2. What do they want me to do with x plus 2? Plug it in for x. So you literally, guys, are writing 3 times, instead of x, you have x plus 2 squared plus 5. This is just an algebra problem. That's it. I have 3 times x plus 2 times x plus 2 plus 5. You got to FOIL first. So x times x. So I have 3 out here. So x times x is x squared. X times 2 is 2x. 2 times x is 2x. And then 2 times 2 is 4, right? Your plus 5's on the end here. Clean up in the middle. What's 2x and 2x? So this is 4x. Not squared. I don't know why I wrote that. Now we can distribute. That 3 times x squared is 3x squared. 3 times 4x is 12x. And 3 times 4 is? 3 times 4 is? 3 times 4 is 12. And then I have my plus 5. So you end up, guys, with 3x squared plus 12x plus 17. You're just foiling. That's it. And then just combining like terms. For the second one, they're asking you to do two things. They're asking you to plug in x. So if I do that, I still have 3x squared plus 5. And then they're asking you to add that to what? What do they want me to plug in the second part? What do they want me to plug in the second part here? They want me to plug in a 3 there. So I have 3 times 3 squared plus 5. I can't do anything with the 3x squared, so I just rewrite it. 3 squared is 9, and 9 times 3 is 27. So you have 5 plus 27 plus 5. This ends up being 3x squared plus what? (3x squared plus what? 37. There you go. Just a funny way of saying, hey, combine like terms. What is the difference in the second example? They look kind of the same. They're having you do two things. They're telling you in the first part of it, plug in x. So when we do that, it just stays as 3x squared. And then they're telling you to add to that whatever the value is when you plug in at 3. So if I look at this, guys, what is the difference here? Does anybody, do you see a difference? Do you see that the 2's are in different spots? All right, in this first one, they want me to take 2x and plug it in for x. In the second one, what do they want the 2 to do? When that 2 is stuck out in front, what do you think they're asking you to do? Multiply it. That's it. So in this first one, they're saying, okay, -6, I'm going to plug in 2x where I see an x, and then plus 4. This one is saying 2 times -6x plus 4. Do you see the difference? When I combine these like terms, -6 and 2 is going to be -12x plus 4. When I multiply by 2, I distribute that 2 and I get -12x plus 8. You do not get the same answer, guys, because you're doing two different things. In the first one, they're telling you take whatever's in that parenthesis and everywhere you see an x, plug that in. In the second one, they're saying take the function and multiply it by 2. Two separate things there. You guys see that? People at home, you see that? All right, one more example. And then you guys should be able to get all of your web assigned done. It's not due till Friday, I know that, but we're going to start tomorrow, 2.2. What are they asking you to do in this case? They gave me the function, x minus 3. What are they asking me to do? They gave me the function, x minus 3. They're asking me to take x squared and put it right there. So this is going to become, instead of x, x squared minus 3. If they gave me this, what do they ask me to do? How's that different? Rewrite it. What's the function? What's f of x? What do they give us? X minus 3, right? They're telling me to put x minus 3, right? This is x minus 3, and then do what to it? Not multiply it. You're going to square it. There is a difference, guys, when they're telling you to take x squared and plug it in the problem, or when they're telling you to take your function and square it. This means x minus 3 times x minus 3. So I'm going to FOIL x squared minus 3x minus 3x plus 9. Combine like terms here, and you get x squared minus 6x plus 9. Two totally different problems here. You have to pay attention to what they're asking you to do. where they're asking you to evaluate, how they're asking you to evaluate. Does that make sense? People at home, how are you?
Good.
Okay. All right. So you should be able to finish up your WebAssign. You guys have a couple minutes. I'm not letting you leave yet. Go ahead and work on your web.